microphone on, please? Is that okay now? Wonderful. Now I can hear more. So good morning, everybody from my side. My name is Antonello Monti. I'm a professor at RWTH Aachen University in Germany. I'm also a group leader in Fraunhofer Center for Digital Energy. And within the foundation, I'm also chairing the TAC. And it's my pleasure today to talk about a project within the Linux Foundation Energy, which is called Sogno, which is an open framework for distribution grid automation. In the presentation, I will give a little bit of the background, how the project developed, and also some recent, very concrete development that we had for the application of the project. I think you heard something like, a bit of noise. We heard maybe 20 times in these last couple of days about the needs of the distribution grid. I think the bottom line is that we have, scary. We have a growing need of automation for the distribution grid. As we heard just in the previous presentation, that's changing radically the role and responsibility of distribution system operator. And this is vital, in my view, to enable a sustainable transition, so making the best possible use of the infrastructure, so avoiding stranded investment. And that's where the digitalization plays a key role. And Sogno wants to give a key contribution on this side, presenting an open framework, flexible, modular, to implement smart services for DSOs. We started this activity within a European context, so in the framework of an Horizon 2020 project, which brings the same name of the platform, Sogno. It was a cooperation with Ericsson, the telecom technology developer, in which we started from the principle that the key element from the automation perspective that we see for the transition is a growing role of the edge. So we have more and more devices to be coordinated, and they're all new type of devices from the point of view of the grid automation and located at the end, at the terminal of the grid. And this is completely changing the perspective, changing from the classical top-down concept to a more bottom-up view for the grid automation. And then we came to the idea of a standard architecture that is captured here. This is actually the official picture you also have in the Linux Foundation website. If I look at the structure of the Sogno platform, we see that it's based on the concept of a message broker that is at the core. And then, because we are microservice architecture, we can implement different services as microservice. And the work we are doing right now is mostly on identifying new services and implementing those new services in the platform. In that respect, it's totally open. So here is a call for contribution and cooperation. We have some of the services running and working, like state estimation being the first one. I always believe from an automation perspective, first of all, you need to know what's going on, then you can think about controlling. So grid monitoring is the key pillar to start with. We are working a lot in fault location identification. We have a new services in optimal power flow that was recently developed, and we are continuously supporting this development with new projects within the research we do at the university. In terms of message broker, we started with MQTT, but we recently expanded to Kafka. And then we have upstreams links to user interface and possibility to develop a dashboard for user connection. The work of the first project, Sogno, was later expanded in a project called Platone, which is actually coming to an end now. We have in the last couple of months of the project where 3 key elements were brought to the concept, and 2 of them are already implemented, let's say, as open services in the Sogno concept. So what Sogno is here in the terminology of this project called DSO Technical Platform. The DSO Technical Platform is the architecture of the Sogno solution, but we realized there were 3 major needs that we were not serving yet. First of all, we start from the idea that any grid operator had some kind of system already in place. They had a control room of some sort. So there was already in place what we call legacy system, classical SCADA they were providing already good services. The no grid operator will like to say, okay, I trash everything I have. Now here comes Sonio. So we have been developing standard interface, 2 legacy systems, so that the normal day and the current services that are working, they don't need to be replaced, at least not today. Maybe sometime will get outdated, and we need a new version, but why changing what it works? And that's, to me, critical from the point of view, as we heard. DSOs are rightly so conservative because they have duties to fulfill. So don't change the daily business and create an opportunity for innovation that is not destroying what is currently working okay. That was one of the basic principles in this project. Platone, we work with 3 big grid operators, so we had a chance to get good requirements. To mention them, one is Areti in city of Rome. I will talk more about them. One is Hedno, the single distribution grid operator of Greece, and another one is Avacon, that is a large grid operator in the north of Germany. The second, we heard the need of flexibility service, so we develop agnostic interface to market platforms so that grid operator can access and develop future market. We don't even know which markets will be. And in another opportunity, which is an options, but this, as I'll show you, been definitely adopted in the city of Rome, for example, is how to engage customers and bring data from the customers. And for that, we developed a blockchain layer, data access layer that allows customers to be connected. Idea here that there was a requirement coming from Areti in Rome is to have a dual use of data from customer. They could be used for grid operation in agreement, of course. At the same time, it's a channel to bring in a dual communication layer that support local market implementations. So this is enriching, and as I say, this is some more information about the project, the location of the demos, and in my university we have a reference implementation where we test things. We have a laboratory with real-time simulations so we can test everything, the full implementation. We have our own cloud implementation local that we can certify software before we give it for the demos to the different grid operators. I'd like to mention specifically from this project one story, then the second will come later because it's even more advanced. But I like this example of the demo we developed with the Avacon. It's a local energy community concept. And we heard a lot about those communities and the problem of finding a good relation between the classical business and the new business. And here what Avacon developed is a win-win situation between the grid operator and a local energy community. The local community is a little town, quite a small village called Twistringen in the north of Germany, where there is a huge installation of renewables. It's a good region for wind, similar to the situation of Texas we heard before. So a lot of pressure because the generation of wind is normally higher than the local need because not so many people live in Twistringen after all. But the idea from the grid operator is that if they build a local community, the local use will facilitate and limit the reverse flow of energy and then will limit the need of grid reinforcement and changes in the infrastructure they should implement. And that's why they implemented our Sonio platform and enriched with flexibility management local platforms that they added as a service that is fit into the German regulation and the specific connection they have with their customers, so that to make the best use of the local assets that you see here, so the photovoltaic that some of the private households have, the local wind in the region, storage, actually adding a large storage capacity at the level of the substation that is serving the community, and then other new loads like heat pumps and electric vehicles that are coming. All that is now optimized and creating a local platforms. What we've been doing in the project is testing also extreme concept just for the sake of validation, like what we were been calling virtual islanding. So what we have in the platform, the possibility to define, according to the requirements of the local community, what should be the power flow at the node of interconnection, so basically the substations. And the community may decide, right now we want to be fully isolated from power flow perspective, but not from transmission, let's say. So they don't overtake role of frequency control and anything. It's just a power flow type of isolation, or setting the level so that they optimize the local consumption respect to the current market conditions and possible price situation. And all those are being running, so that's also why we've been working on developing optimal power flow, so that this can be tested, calculated, scheduled, and optimized, and then locally implemented, thanks to the capability of flexibility that is installed locally. In this process, then we migrated in the Linux Foundation. Now we have been now for a couple of years as an official project in the Linux Foundation, and we have been working to expand the community in the last couple of years so that we fit now perfectly in the structure, in the general architecture. This is probably a picture I've seen several times about LFE, and you can see Sonio located on the top as a system level type of concept. And we have a growing community and a growing set of projects, because in my research group now, every time we have a new project, we try to look at how the Sonio platform can help. So you see some of the partners, industrial partners working with us. You see it's not anymore just a university, but we have a growing set of companies working with us. And on the bottom, you see the research projects which are feeding the platform, and some of them are still running, like OneNet and Be Flexible and Flow are actually two recent projects that started, and are bringing new ideas and new services in the project. We have been working also to understand how Sonio fits. I think one of the key jobs we have to do in the next couple of years in the foundation in general, how those great resources, the different projects can work together. So we had here the first experiment of incorporating Fledge Power and creating then a synergy between Fledge Power and Sonio. It doesn't make sense Sonio replicates what is there. So this has been a successful done and implemented, so that we have a demo running with Fledge Power. And same times, as I mentioned, with the new project, we are developing new services. The key topic that is emerging for us is a new type of service, is optimization of charging from electric vehicles. It's a topic that is coming up more and more, and looking at the DSO as a service provider in the middle that helps, under the assumption that several provider of mobility may be in the same region, and then helping customers to find the best way and the best routing for charging, and integrating this within the platform. We are looking at other expansion and interaction with project. Here, another work we are doing is integrate with OpenADRs and the project Open Leader. So making sure that the overall ecosystem, we are the automation concept, the service at system level, but we need all those other ancillary and component to build the full picture of digitalization of a DSO. In conclusion, we'd like to go to what is our best practice story, which is the RoamFlex project. Basically, the RAT, the distribution system operator for the city of Rome, was one of our partners in the Platone project, the project I described before. And they were so convinced by the experience in the project, they decided to completely restructuring their way of working and their DMS. So they were in the moment of transitioning and say, we need a new DMS, and how do we do it? And they used the Platone experience to understand what was the best way. Their conclusion is, we go open source, we go Linux Foundation, we use Sonio. So they released an open call for projects to companies and saying, you can provide us and offer the service of a new platform, but has to be open source, has to be LFE, has to be based on Sonio. And so this is, for us, the best success story. City of Rome is the biggest city-level grid in Europe in terms of number of customers. So if we make it in Rome, we can make it everywhere in Europe. And what is really important for me is also that this was a decision driven by clear business analysis, not techie-driven. Of course, we support automation, digitalization. This is my work. But what's interesting is that they sit down and calculated, how do we build a sustainable transition for the city of Rome? We have a challenge. The load is growing dramatically in the next 10 years because electric vehicles and heat pumps, or air conditioning even more, given the location. So those loads are coming, and we will need a dramatic growth in the need of installed power. They made a calculation. We cannot make it simply reinforcing the grid. We cannot make it economically. And so they came up to the idea that there is a trade-off between investing in the grid and investing in digitalization. And they brought us to a map of development on how digitalization should be appearing in the grid so that they can access services up to the point that they will need 250 gigawatt hour of flexibility services in 2032. At the end, that means 50% of the growth will be covered by digitalization, cutting 50% of the cost of grid reinforcement. These are their calculations, so these are business data, not university thinking. So they built a complete solution in which at the core, you see they call it here DSO technical platform, bottom line, the Sonio platforms, integrating with the other platform, they build the ecosystems to enable a specific market implementation coming from the Platone platform itself and linking to a market platform coming from the Italian regulation. And then other tools like the flexibility register and the balance party connection. So the all connection to TSO and to local markets are now integrated into an ecosystem that at the center has Sonio. And the point is from them is it's a changing world. They cannot go for one proprietary solution because they don't know what they need tomorrow. This is the key driver for them to say Sonio has to be our solution, and that's why they went for it. And you can see also they implemented the access layer of blockchain and equipping any customer in Rome now with a box called Lightnode that will allow a local blockchain connection so that for secure data exchange between DSO and any customer in Rome. It will take time to come there, but their equipment is going section by section of the grid to make that in the whole city. Yeah, here a bit more on the details on the DSO technical platforms and the different interfaces and the services. They are, as I mentioned, starting from the state estimation part, and that's the input for forecasting. They identify possible congestion and voltage violation, and that triggers the need of flexibility market. And then the same platform is used to validate if the provided services are actually able to solve the problem. What you see here in the picture, also the little box there, is exactly this light node I mentioned that is the link for the customer to become part of the system. So they also have been really innovative in creating a real condition for every citizen to be part of the game, which is one of the key elements of the energy transition. Yeah, so just coming to the conclusion, Sonio is now basically a market-ready solution. It is going in production now in Rome. We expect other cities in Italy to follow because the regulator in Italy say, that's a solution that works, just go for it. So we are discussing, for example, with the city of Milan to follow the same route. So that will be another couple of millions of customers in Italy that will use the Sonio platform. We use other projects to continue, so we have a stream of funding, so that's solid. We're actually developing a large program in Fraunhofer to build this as German as standard for the old German system. So similar to the Italian experience, do it in Germany as well. Our community is growing, but we welcome more to come. And real projects are emerging, as Ron Flex showed. I would like to conclude with just a little bit of advertising. The Platone project will have its final event in Brussels, where we will discuss, present the results. So it's we invited, of course, the European Commission. You are all invited to come for the final event that you see here will be on the 28th of June to see live what we have been doing. Areti will be there talking about their real life big deployment they're doing, but also other technology developed within the project supporting flexibility will be presented and discussed, also with some roundtables, one specifically on open source will be a key topic that we want to bring to the meeting. I thank you for your attention, and of course, yeah, I made it in the right time. There's still time for questions before all can break out for lunch. Thank you. Any question? Please.
Similar question to what I had before. Very impressive work, and I'm impressed by the city of Rome just saying that's the way we want to go. What's your experience with them as a DSO? Were they very much asking for it, or was it a door that you really had to bang on and convince them that this was actually going to work for them? What's the experience on the Italian side of that?
I must say, I think the project, so the opportunity to work together in an Horizon project for 4 years was a way to convince them day by day. So we didn't have to do a selling pitch. We did the work. They saw the effects. So they were impressed how, with this concept and the openness of the platform, things were coming into operation in a time they never experienced before. So in the project, they say, okay, we need this new microservice. Okay, here it is. Oh, we add it to the platform, we run. So they were like, what? You know, they were used to the normal cycle. And that for them is say, okay, this is a key element for the transition, because I heard it also from a presentation yesterday from Alianda. We don't know what we need in 2 or 3 years. So we cannot lock in ourselves to anything. That's where those principles are so critical. That's why open source, and that's why going for a microservice architecture, because I don't know what new regulation will come. In Germany, we have a redispatch X.0 every 2 or 3 years that brings completely new requirements. Grid operator cannot just keep up, and also for the software developers in Germany is a nightmare, because even large, that's why a company like PSI are joining, because also for them alone is too much. So I think it was a day-by-day process with real experience more than a couple of slides.
And what was the size of this real experience? How many consumers?
It was one city quarter in Rome. I don't remember exactly, but it was one portion of the city under one of the, a couple of secondary substations, I think. The other demos were similar. I mean, in Germany was one primary substation, basically, so the full little town of Twistringen. And in Athens, we are running a demo where we have a portion of the grid outside Athens involved.
And what was the experience in Germany and Greece, since I guess they are not implementing the platform right away?
Yeah, I can say that the grid of Avacon is doing a follow-up project with us in Germany now that we hope will be approved. We are quite optimistic. It's part of one of the biggest projects in Germany called the Copernicus program. We have to go for the phase 3 on real deployment. And it will be a very interesting development for the Sonio platform, because for the first time, we will put on the field a concept that is not even tested here in Rome, which is, thanks to the concept of data broker, we can build a hierarchical structure and having a distributed solution. So we will have 4 or 5 substations, each one running a version of the Sonio platform on the edge, and then having a local state estimation only for that portion, and then bringing data up to a second layer of data broker that is decentralized in the control room. And then this way proving the possibility of a complete scalability of the platform down to the low voltage, which is one of the key problems for DSOs, because the classical SCADA they have right now are not able to scale to low voltage. So they can cover the medium voltage quite well, but when they have to scale to low voltage, they need those edge solutions. And with the platform we have, we conceptually in the lab already demonstrated this possibility. This will be the in field when we have Sonio Edge implemented, so the same platform replicated locally in a substation. Very likely will run in a very low-cost platform like a Raspberry Pi, just for, or something of that level, and having just the local low voltage that way, and then aggregating at a higher level, but minimizing the data traffic from the control room perspective. Other questions? Please.
I understand that software is a microservice-based framework. If I am a new developer who want to contribute more like calculation for or any other components to software, what would you suggest to start?
We have already I know in which project you're active, so it will make a lot of sense to have a connection, because we already have developed, probably was something that goes in that direction. Let me see if I find quickly the slide, because we also have developed, yeah, here it is. We have developed this interface in the past, because we have also have a real-time simulation platform we developed, which is open source and also part of Linux Foundation, which is called DPSim, so that we test in real-time services before we implement. So we already have exchange with calculation systems, and we have this system here called VILLAS, Virtual Integrated Laboratory for Large System Simulation. That's another open source project, for the moment not in the foundation, but is open source, to create data stream exchange for simulation and calculation. It's specifically designed. It's been developed to connect laboratory in real time to perform joint experiment, but at the end, it's a programmable data stream system. So it can be used to interface to any kind of calculation system. And here we do it with our own system, but we could link to other type of calculation systems for sure. Any other questions? Or I can understand the lunch is more appealing than the Sonio platform. Oh, perfect. 42. Thank you very much for your attention, and enjoy the break.